So we're going to talk about evaluating and solving exponential equations. And this is not hard if you will pay attention. Okay, not hard if you'll pay attention. So the first one says for the function f of x equals 1200 times 1 plus 0.04 to the x, we're going to evaluate f of 2. We've learned about this. Remember, this is the same thing as f of x. So the 2 replace the x. That's exactly what it tells you, is that 2 replaces the x. So if we write our function down, the only x is up here, so we're going to plug in the 2 up there. And then we're literally going to put it into our calculator. So 1200 times 1 plus 0.04 to the second. And we get 1297.92. That's all you do. So what does B tell us? What do we replace x with? What do we replace x with in B? 1.5. So this one says that 1.5 replaces x. In our function, again, same function, there's only that one x. So we're going to write it again, 1 plus 0.04 to the 1.5. We'll put it in our calculator. And we get 1272 point, I'm going to round it to 72. That's it. Nothing crazy. What do we do on C? Plug in 0. So the same function, and instead of x, we're going to put in 0. And we get 1200. Just a reminder, remember anything to the 0 power, we can cross out. So that's why it ends up being 1200. Don't forget that. All right. So now they change it to G because we have a new function, 365, 1.5 to the x. But we're doing the same thing, just a new function. So our function this time is 365 times 1.5 to the x. On A, what are we doing? What are we doing for this one? Thank you. Somebody else can answer, and that would be amazing. At this point, you should know exactly what's going on. 1.5, you should see that's a 1.5 to the 1, and we get 547.5. Same thing on the next one. We're going to use that same function G, but for the x, we're going to plug in -3. 365 times 1.5 to the -3 gives us 108.15. $108.15. And then the last one, you're going to take the function and for x plug in 2.3. So we're going to do 365 times 1.5 to the 2.3. And we get 927.48. All right. So on your next one, see how it's a little bit different? We still have our x's, so we're not plugging in for x. Does everybody see that? We're leaving the x alone. What this says is just set it equal to 0. Set it equal to 6. Set it equal to 20. So set equal to 0. So you're going to take that 50 right here, 50 times 0.85 to the x, and set it equal to 0. What I would suggest on this one, and I'm going to stop sharing for a minute. And there it is. Share Desmos with you. Remember how we do these? One side. Goes in one side, and you can either put y equals or you can type the whole function. You can type it in and see what happens. Notice I don't see anything. I don't really like this one. Let's do it this way. Equals y, and y equals 0. Makes it a little bit easier. So we're going to type those two functions in. The only reason I put y equals is because we're going to put one side in the front and that 0 the other side in the second one. And then we're going to see where they cross. I'm going to have to move it over and check out that point where they cross. Only on the blue one. It's really far away. I don't like it this way either. Let's see. Let's see if we can look at our table. Let me stop sharing this. Is there a, hold on a minute, I might can do it different. Let me go back to that. You said when we put it in like this.
You gotta have it y equals.
It is in y equals. But it won't make it.
I think the y has to come first.
I don't know. I want to see that.
The problem with the table is that it was only showing like a certain.
There it is.
A certain amount of numbers, like it didn't go about 2.
Gotcha.
Go higher if you need to go higher.
Gotcha. Wonder if you can change them.
I don't know.
Yes, you can. You can change them. Let's see. Yeah, I don't really like it on this either.
We end up using calculator for that.
Let's do that. I thought it'd be easier on Desmos. Sorry, y'all. All right. So 50 times 0.85 to the x and 0 what? Okay.
That was weird anyway.
Yeah. I'm going to zoom regular, and you're probably not going to see anything. We're going to try. There's the red line. So I'm going to zoom out. I'm going to look at the table in a minute too. So this is one way you could do it, and then I'm going to check the table as well. So when you see the blue line and the red line, you can do second trace intersect. So second is the blue key, trace is up here, intersect is number 5, and you're going to enter 3 times. and it'll give you an answer. Oh, it's not on there. Hold on. Zoom out one more time. And now we'll try it. Second trace intersect.
Is that the first one?
Yeah.
That's,
Was it really weird for her too?
yeah, she sometimes it showed that, but they never intersect.
And that's, but I want them to, I don't know.
Now, the next one worked out exactly right. That one.
Hold on. Let me show you the table. Maybe that'll help too. We need to change that. Remind me, and I'll tell Jenny too. Yeah, so it's not going there. So these don't intersect. So just mark this one out. Ignore that I even put that one on there or that we did it. We'll do it with 6 this time. So the next one is that with 6. I thought it was just really, really small.
No.
All right. It's going to equal 6. So it's not going to show up on my calculator just yet. I just went to a regular screen, so I wasn't in the crazy spot. You should see the red line go across. All right, so now I'm going to zoom out. You can also do zoom fit, and that will help you. I'll try to do that on the next one. And then we can see that they actually cross on this one. That's what she was saying, is they didn't cross. They're not parallel, but they were kind of like that. And your exponential shouldn't cross 0 anyway, unless they're added or subtracted. So that was just a really crappy problem. All right, so second trace intersect, enter 3 times. And you'll see that your intersection is at 13.04. And why are we looking for x? That's the only variable left in the problem. So don't forget that. On the next one, we're just setting it equal to 20. So 50 times 0.85 to the x equals 20. I went back to a regular screen. Remember, on the regular screen, you're not going to see anything because it's only 10 to negative 10. Okay, so this value is 20, so it's way above it. I'm just watching this little circle, waiting on it to finish. When it finishes, I know I can do something else. I'm going to zoom fit. That's a 0. You guys see that 0 down there? Zoom 0. And that'll help me find both graphs. It may not see the intersection, but at least you'll see both lines. Okay, so there's the one line. Can I see the intersection? This one was a good one, so I could. Second trace, intersect, enter, enter, enter. And I got x is 5.64. I don't care if you round or not. It's up to you. Okay. So the thing is, there is no other way for you to be able to do that. You will not learn how to solve exponentials for real until Math 3. Okay, so you have to use the calculator for those. Got it? There's no other way. You can also, if it's multiple choice, plug in your values for x, so that way you don't have to do all the calculator stuff, and see which one gets you closest to 6 and 20. All right, so number 4 is back to being like number 1 and 2. So we're going to take, number 4 is like number 3. We're going to take our function and set it equal to 20. So it's the same thing that we just had, just a new function, 100.25 to the x. I'm going to zoom 0 and hope that I see both. Okay, they're way down at the bottom. You can zoom out if you want to, or you can just go ahead and try to intersect. If you can intersect, it'll show you. If not, you may want to zoom out. So we could see it, and it's at x equals 1.16. Again, that's all you have to do. So for this one, instead of 20, we're doing 10. So 100 times 0.25 to the x equals 10. I'm going to go ahead and graph it. You may not be able to see it. I'll zoom fit after that. I do see my red line. We can try it. Second trace intersect, enter, enter, enter. And we got 1.66. Doing the same thing on the next one, it's just equal to 55. So all you're going to change is your second y equals to 55. I'm going to go ahead and graph and see if I can see my intersection. And I see my red line down there, so I'm going to try it. And we get 0.431. Any questions? Okay, so check this out one more time. If the 1 is inside the parentheses, anything inside the parentheses goes inside the equation. Got it? Inside goes inside. If it's outside the equal marks, it goes outside the equation. Got it? These are the ones that are the most missed because you try to plug them in. We don't want to plug those in. They're outside of the equation. All right, let's look at your next ones. It says verify solutions on the graph and in the calculator. Verify the solutions. So you will have questions like this on your final exam. What you have right here is a -2 is equal to 18. This is a coordinate. Is -2, 18 on the graph? -2, 18. So we go to -2 and we go up. Is that point on the graph? We go over -2, up 18. Is that point on that line? Yes. So you just write yes. What's your next coordinate? What's your next coordinate? If this one was -2, 18, what's your next one? 0, 4. That means go over 0 and up 4. Is that point on the line? I drew it right here. Is it on the line? No. That's all you're doing. The last coordinate is 2, 0.2222. That means we go over 2 and up 0.2. This one looks like it is on the line, right? We're going to assume that it is. The next one just went ahead and gave you the points. They wrote it out. They made it easy. You don't have to do anything hard. So the first one is -5, +2. Is that point on the line? -5, +2. Yes or no? No. Here's the line, right at 0 and moving up. That point is nowhere near that line. The next one is 1, 1.3. So I'm going to go over 1 and up 1 1/3. Is that point on the line? Yes. That's all you do. And then we're going to look for 4 and 20. Is that point on the line? No. So we just write a no. So they do the same thing with the function. They just want you to put it in the calculator and check the table. Okay, so look at your next one. They didn't graph it. They want you to, but you don't have to graph. We have 15 parentheses 1/4 to the x. You shouldn't have anything in y2. We're going to look at the table. So second graph. And I'm really far up. So let me get my table start to 0. All right. I need -1. Is it -160 on my table? Read my table. Does it say -160? Yes. Then that's a yes. Read my table again at -3. Is it 150? No, that's all you do. Just read your table. Is that point there or not? So we'll do it again with your new function. Your new function is 4 parentheses 3 to the x. Check your table, second graph. We're looking for 5, 972. Here's 5. Is 972 beside it? Yes. We're looking for 2, 28. Is 28 beside 2? No, it is not. That's all you're doing. All right. Again, just checking. Use y equals in a table to verify those 2 points, okay? All right, so exercise 3, remember this point is an XY coordinate. So what they want you to do is find the value of K. So we're gonna rewrite this. And we're gonna plug in what we know. What's our Y? What's our Y? I cannot make it any plainer on this screen. You have to open your mouth. Yes, Y is 27. What is your X? 3. We're looking for K. You can guess and check on this because these are going to be really small. If they're really large, you can use your graph. It doesn't matter. Like I showed you the 3K in one side and the 27 in the other. Or you can just guess. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. 3 to the third is 27. So K would equal 3. Okay. You can also do it this way. 3 to the X and 27. Like we did on the other one. We're going to zoom fit it so we can see it. There's your blue one. There's your red one. Second trace intersect. And what do we get? 3. I don't care which way you do it. Okay. Guess and check is probably going to be faster on this than graphing it, waiting on it to graph, second trace intersect. All right. So with your next one, here's your point. We have X and Y coordinate. We get Y equals 2 to the K. What is our Y? And we're not using our X on this one. We just used Y. So plug it in. We know that 2 squared is 4. 2 to the third is 8. So that's all you do. 2 to the third. All right. When you're done, flip it over. All right, solve an equation or inequality using calculator or table. So to solve these, did she use Desmos on these at all?
No, I think we just have to-
Okay, I might go back to Desmos in just a minute. Clear that out. Go into Y equals. One side in Y1, just like we've been doing, 3 minus 2X. The other side in Y2. I'm going to regular zoom on this one. There's my blue line. It's still working. I can't do anything till this little circle goes away. There's my second one. I'm going to try second trace intersect to get the answer. What do we get for X? Can y'all see it? What do we get for X? It is 3. It is 3. That's literally all you do. Okay, you just got to make sure you can see that intersection. And remember, we're only looking for X because that's all we have in the problem is an X. So don't worry about the Y. It doesn't mean anything. Just the X is what you want. Okay. I'm going to do the one right below it just since my calculator's covering up everything else. We're going to have negative X plus 5. And then we're going to have 2 times 1/2 to the X. I'm going to graph it. Hopefully I can see the intersection. If not, I'll play around with it and find it. There's your first side. There's your second side. Oh, what do you notice on this one? Crosses twice. So how many answers should there be? 2. So we're going to do second trace intersect twice. So here's what I do. Second trace intersect. And I go to one of the crosses and enter 3 times. So your first one, just your x, is negative 1.76. And then you have to do it again. Second trace intersect. So second trace intersect, but I move it over to the other intersection like that. Enter, 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 and I get 4.93. That's it. So if it has 2, you just have to do it twice. Not a big deal. All right, everybody good with those 2? We'll switch to the other side. Clear these out. 3 times 2 to the x on one side. 6x minus 7 on the other. I'm going to graph it. Can I see my intersection? No, so I want to zoom out and see if I see it this time. What do you notice? So this will be no solution. And that's what we should have seen in the first one. All right, finishing up the last one. 2x plus 3, 2 to the x. We're going to graph it. And my graph is still crazy from the last time. That's not a big deal. How many intersections do you see? Yeah, I'm going to zoom 6 to see if that helps us see both of them. If we can't, I'll mess with it a little bit more. Yeah, so there's one, and there's the second one. So second trace intersect. Oh, second trace intersect. Enter, enter, enter. For this one, we get negative 1.296. If you just wanted to put negative 1.29 or negative 1.3, that's fine. We do second trace intersect and move it up to the top where it intersects. And we get 3.247. Any questions? That's literally it. All right. So the next ones are just word problems. Suppose that 2 types of bacteria which coexist grow at different rates. So this is 1 bacteria and this is 2 bacterias. Which function T of X models the total amount of bacteria present after X hours? So what does total mean? If you're going to total something, what are you going to do? Add it all up. So we're going to have 2 times 5 to the x, and we're going to add it to 3x plus 2. That's it. It's not asking you to solve it. It's just asking you to write a function, and that's what it says, which function. So this will probably be a multiple choice, okay? Multiple choice on your final exam. That's it. There's nothing else to do. It just says write a function. Suppose that the 2 types of bacteria which coexist grow at different rates. They're the same thing. Models the amount of the second type of bacteria. Which function models when the 2 are the same amount? What does the same mean? That they are what? Equal. All it's asking you to do is write a function, and this time you're going to write an equals function. This one was an add function. So to do equals, we're going to take our 2 function and set it equal to each other. And that's it. It doesn't want you to solve. Any questions? Everybody good? All right. Last page. These are on your final exam a lot. Okay, a lot. So it says find k when f of x equals 50 times 0.85 to the x. If f of 2 equals k times f of 1. All right, you just follow what it says. Remember when we had 2 on the inside, what did we do? What do we do when we had 2 on the inside? Numbers 1 and 2. First two things we did. You put it in for x, right? You plug it in. So if it's inside, you plug it in. So we're going to do 50 times 0.85 to the 2. It says plug it in. Equals, we're going to write that k because we don't have anything for k. And then when we have a 1 inside, I'm going to make a bracket so you can tell the difference. We're going to plug in 1. These two can go in your calculator. So we're going to do it separately, put it in our calculator. So 50 parentheses 0.85 to the second is 36.125. 50 times 0.85 to the 1 is 42.5. And then you throw the k in the back. Now this is an equation we know how to solve. It's just ugly decimals. So what are we trying to solve for in this equation? What's the only letter we have? K. How do you get your k by itself? Divide it. Absolutely. Perfect. So 36.125 divided by 42.5 gives me that k equals 0.85. That's it. All right, the next one is exactly the same. We're going to plug in 3 and we're going to plug in 6 and we should get about the same thing, okay? So plug in 3, so 15 times 2 to the third equals k 15 times 2 to the 6th. Fifteen times 2 to the third is 120. That's a nicer number. 15 times 2 to the 6th is 960, and we have a k. How do I solve for k? Divide 960. Put in your calculator like you see it. 120 divided 960. K is 0.125. Your next one is exactly the same. The only difference is it's plus instead of multiply. It's not k times that function, it's k plus that function. So how do we get rid of a plus? Minus. Okay, so in the end, instead of dividing, we're going to subtract. All right, so we're going to plug in -3. So 2 to the 1/3 times -3 equals k plus 2 times 1/3 to the -6. So I'm going to plug this side in. It gives me 54. We have k plus 2 times 1/3 to the -6, which gives you 1458. And then you said to solve, we subtract 58. So 54 minus 1458 gives us -1404. So plug in and solve. Very last one, plug in 2 and plug in 1. So 50 times 5 to the 2 equals k plus 50 times 5 to the 1. And those two numbers come from your numbers inside. 50 times 5 to the second is 1250 equals k plus 50 times 5 to the 1, which is 250. How do I solve for k? Is I add 250. So I subtract 250. And I get 1000 equals k. Any questions? Your homework today looks exactly like these notes, so I suggest that you probably leave them out. If you have the packet, you have the homework right behind it. All right. I'm going to stop sharing, stop recording.